torque is a physics idea that kind of measures the amount of twist in something, and the definition is on the front page of your notes. So number 19 is an example that we can work off of.
Yeah, I mean, it's on 19,
The true definition of torque is a vector. It's the cross product of your position vector, or it's sort of a position vector that it's telling you a direction of, you know, something, and then this is a force. So torque itself is a vector. And notice it's the cross product of two other vectors, so it's perpendicular to the motion. So I know this picture might be a little hard to figure out, but again, I copied it out of your book. Imagine this is a pedal on a bike, okay? So you're pushing up here, but the motion's occurring, and the twist is occurring here. So if I push here, it's affecting the turn here. So the torque is going to be coming out, you know, at us from the way this picture is drawn. Okay, my torque is perpendicular to both of those vectors. So this is a vector kind of representing my displacement, and then that's the vector representing the force. The magnitude of the torque is equal to the magnitude of the cross product, but this is equivalent to the magnitude of both of those other vectors times sine of the angle in between the vectors. I can't remember if I drew a picture on your notes of that, but I know your book, if you're in section 12.4, your book has a nice little picture of why that's true. Let me see if I can find the page number. Yeah, it's on page 835, so I'll just kind of put the page number down right here. Page 835 is where they're drawing a little picture and kind of talking about that. In your textbook, so that's why I'm going to kind of just focus on what your textbook tends to have you worry about. I'm not sure in physics if your focus tends to be more about the magnitude of the torque. But all the problems in your book, they have you just find the magnitude of the torque. They don't actually have you find the torque. But I do want to emphasize the torque itself is not the magnitude. It is a vector. And it is a vector perpendicular to your force vector and your displacement vector. So I don't know, some of you in physics, I'm just curious, when you work with torque in physics, do you tend to just sort of focus on the magnitude, or has anybody gotten that?
They actually have you do
Find the actual vector.
the actual vector as a cross product.
Okay, I was just curious, because I found it sort of interesting that the book, every single question in your book just has you find the magnitude of it, so I was curious why that was the case.
They actually had us separate it out into component vectors first, then cross multiply, and then.
Then do the cross product and then.
And then you got a result.
Yeah, okay. I know, that's interesting. I mean, to me, that makes sense. I just was, it's been a while since I had done physics problems myself. Like the way this problem's presented in your book, you actually have to do a little bit of work to define the vectors. I mean, you can define this as your origin, but you would, need to figure out, well, what am I gonna use for X and Y if, I guess we can go ahead and do that. So if I have that as the origin, then this point right here would be negative 18 cosine, hang on, I gotta be careful here, because I think they're telling us this is 10 degrees. So if that's 10 degrees, this is also 10 degrees from alternating angles being equal. So this is also 10 degrees. So
Should it be negative 1.8 compared to?
oh, well, you know what, you're right, since we have newtons, it actually would be 0.1, right? If we're gonna turn it into meters. Yeah, what Warren is pointing out, that the length of the pedal shaft is 18 centimeters, but they've given us the force in newtons, and so when you talk about the scientific units, you really should have your measurement in meters, not in centimeters. So 18 centimeters is 0.18 of a meter. So that's what he was bringing up. So then my Y is 0.18 sine of 10 degrees. Okay, if I'm treating this point as my origin. Okay, and Z would be coming out at us, the way we have it, I have Z coming out at us. Alright, so then, this is the way I understand it, like, they have that drawn, pushing on the pedal, but it's causing a turn here. So you wanna sort of pick that up and imagine it coming out here, if you're gonna actually find your vectors. And they tell us that this angle is 70, so I have to think through, that would make this 70 also. Okay, because this is parallel to this, and if I pick that up, those would be alternating. Okay, so this terminal point there would be negative 60 cosine of 70 degrees, negative 60 sine of 70 degrees. And then your Z is 0, because you're kind of picturing this whole thing in the XY plane. So if we did find torque, the actual vector that is the torque, I would be crossing R, so negative 0.18 cosine of 10, I'm just leaving these exact, 0.18 sine of 10 degrees, 0, and then negative 60 cosine of 70, negative 60 sine of 70, 0. So notice I would be 0, 0. J would be 0, 0. Again, this is no surprise because the cross product is perpendicular to both of those vectors. If both of those vectors are lying in the XY plane, then your torque has to be parallel to Z. And so it's no surprise that when I do my cross product, I'm getting 0, 0 for I, 0, 0 for J, but then the K will be negative 0.18 cosine of 10 degrees times negative 60 sine of 70 degrees minus 0.18 sine of 10 degrees times 60 cosine of 70 degrees. And that's my K. I only have a K direction because, my vector is pointing out in the Z direction. Make sure your calculator is in, degree mode, if you're typing in the exact same thing I am. You know what, this is close enough to be in 10, I'm just gonna put 10. Sorry, I'm just making sure my eyes are pretty picture. And then this would end up being a, so that's negative, so then we get plus 2, so I get 10.64142 K, all right? So the magnitude of the torque, which is the magnitude of my cross product from our work that we've just done, is 10.64142. It's a vector itself, and it's a force itself, right? So the unit would be all right, if you did it the way the book intended us to do it, we would multiply 0.18 by 60, and then take sine of 80 degrees. Where am I getting 80 degrees?
70 and 10.
Exactly, it's the angle in between them. So the angle in between them is 80 degrees. So if you take 0.18 times 60 times sine of 80, oh, we're off, well, I'm off a little bit because remember I said this is close enough to 10, I'm just gonna say 10. Okay, so if you do this, you get 10.6359. It's off due to me rounding the initial 9.99 for something to 10. It's off by just a little bit.
It's all about the fraction.
Yeah, which I guess to be, yes.
Is there a reason we would do the cross multiply way versus the way the book says?
Well, I mean, that's what I was asking people who are currently in physics. I'm like, in physics, do they just deal with the magnitude? Like in terms of torque, do you really only care about the magnitude? Is that why our book is only focusing on that? And then Robert was saying, well, no, they actually do have you find the vector. So I was kind of going over it from a physics point of view.
And that may have just been my instructor, because I mean, she did, after making us go through several that way, she did switch that, and it's
Yeah.
just like they used it.
Well, I guess you're
I think
getting
I'm
your
like the
money's worth.
only,
You're getting your money's worth.
I think I'm the only non-engineer in here, or physics related person.
Okay.
All right,
So Will, you're getting your money's worth, okay? So
Yeah.
basically, we got the same answer doing it your way. I mean, in terms of quizzes and tests, I'm going to leave it kind of the way what the book is emphasizing, but I do think it's important for you guys to realize this itself is not the torque. The torque is a vector representing a force. I'm sorry, was there another hand up, or was it just Robert stretching? I just, out of the corner of my eye, I thought I saw.
Yeah, so you're saying that that's not the torque, okay?
Well, this is the torque, because by putting the K, I'm making it a vector. So it's a force vector, whereas this number by itself is not the torque. It's the magnitude of it. But by the way we set the problem up, we put our force and our displacement in the XY plane. So our torque is perpendicular to the XY plane, hence it points in the Z direction. So my vector only contains Z, so its magnitude is just whatever this is. That's probably one reason why the book just focuses on the magnitude of it, because all those all the beginning problems, you set it up the way we did, where you make the coordinates easy to work with by putting them in the XY plane. If you do that, then your torque is gonna be perpendicular to it, and you're only going to have a Z coordinate. So if you only have one coordinate, the magnitude is the component of it. So that, but you should understand that torque is a vector. So if you had a more complicated system where there was a reason why, you know, your two vectors are really out in space and they're not necessarily nicely placed in the XY plane, then, you know, your torque vector might have an I and a J and a K.